Been kind of nervous about doing this one. So just a few caveats. You guys are probably going to be, I'm trying not to bore everybody with this because some of it's a little technical. By the end, some of you may have already heard of some of the stuff I'm going to say. Some of you may not. You might either think I'm onto something, or you may want to start throwing fruit at me and lettuce and avocados and So it's going to be interesting, but we'll go through it. I do have a couple of videos in here. I'm going to see if I can get them to sound because there's some good ones. Anyway, so let's start with this, and I really want to play this. Where's the speaker on this sucker?
That's a good question. Go ahead and turn it on. Let's see. I'll use this mic.
Who's looking at this carefully realizes that there's a distinct anti-science flavor to this. So it's easy to criticize, but they're really criticizing science because I represent science. And if you're attacking me, you're really attacking science. I mean, everybody knows that.
So did y'all hear that? Yeah. If you're attacking me, you're attacking science. Everybody knows that. Okay. So we've heard a lot in the last 2 years about science, trust the science, blah, blah, blah. I will go ahead and tell you right now, about 99.99999% of people have no idea what science is. And that includes him, and it includes most people who actually work as scientists, okay? Because I've talked to a lot of them over the last 2 years, and that's a big deal. But we're going to go through and talk about science real quick before I get on to the main topic, because this is important. So I'm sure you guys have seen Neil Tyson Neil deGrasse Tyson. The good thing about science is that it's true whether or not you believe in it. Okay, he doesn't know what science is. In evidence we trust. Yeah, that sounds great. Let's keep going. What is science? Is this science? Best way to parallel park on a crowded street according to science. That have anything to do with science? How about this? Scientists discover a self-destruct button for the entire universe. Really? Scientists discovered that. That's amazing. How about laundry science? Get ready, get set, get dry. Is that science? It's a science project. Apparently it's science they're teaching kids. How about that? That's our new cosmology. That's what they tell you right now, that you're flying through an endless nothing with everything rotating like that. Is that science? How about that? Yeah, is that science? So that's a good question. Yeah, that was, I don't know who that was. So none of those were science, okay? Science is a method. And science as a method only deals with cause and effect relationships in the natural world. Okay, that's a big deal. So definition of natural science. Science, such as biology, chemistry, or physics, it deals with the objects, phenomena, or laws of nature and physical world. That's close. Natural science, a major branch of science that tries to explain and predict nature's phenomena based on empirical evidence. Getting better. In natural science, hypothesis must be verified scientifically to be regarded as scientific theory. Big deal here, okay? So the reason I'm bringing this up, because everybody hears the word science thrown around. If you don't know what the term means, you're going to just accept what anybody says is science. And because people use the word to lend credence to what they're claiming. Because deep down, people equate science with being truth, okay? Colloquially, science just means knowledge. Well, I can have knowledge that I'm standing up here right now talking to you. That doesn't mean it's scientific, okay? We're talking about natural science, especially when it comes to the shenanigans over the last 2 years. So that's what we're dealing with. So definitions matter, just like we talked about in the first one. And the reason you can know what science is because you can know what it's not. So there's a definition of pseudoscience. Collection of beliefs or practices mistakenly regarded as being based on the scientific method. Oh, there we go. Now we have a qualifier. So we can know if something's actually scientific or not if it's gone through the scientific method. Well, that's a big deal. So this is what I encourage people, and I've been harping on this now for a year and a half online and all over the internet and Twitter, and really going after some of these guys who start talking about science, and I'll start bringing up scientific method, asking for specifics, and they don't have a clue, most of them even, what the scientific method is, okay? That's a really scary thing that I've discovered. So let's talk about the scientific method real quick because this makes it easy. And y'all may not be able to see this. It's kind of small. Scientific method is an approach to seeking knowledge that involves forming and testing a hypothesis. We all learn this in like 3rd or 5th grade, and then it's forgotten. We just forget it all. Scientific method provides a logical, systematic way to answer questions and removes subjectivity by requiring each answer to be authenticated with objective evidence, blah, blah, blah. The goal is to validate or invalidate the presumed cause of an effect. That's a big deal. You have to have an effect, which is a phenomenon in the natural world, and then you try to figure out what's causing it. Science does not deal with what is questions. Science does not deal with descriptions. Science does not deal with the shape of objects. Okay? Science does not deal with how good a medicine works or not. Those are statistical studies. Those are case controls and randomized controlled trials. Those are not trying to find out the cause of a natural phenomenon. That's what natural science is. Okay? That's a big deal because you can start holding people's feet to the fire when they start throwing around the word science. An experiment following, I think I said that, experiment following the scientific method will feature an independent variable and a dependent variable. This is massive. Anytime somebody claims they have a scientific experiment, you first ask them, what's your dependent variable? Dependent variable is the phenomenon under study. It's the thing that you saw in nature happening that you're trying to figure out what's causing it. The independent variable is your presumed cause. That's the thing the researcher has to manipulate and vary to see if it causes what it is claimed to cause or you believe it to cause. So that's pretty simple. It's actually very logical. We all kind of, the way I've couched it to put it in just layman's terms, if you claim X causes Y, X has to be real, and you have to show that it causes Y. We all get that. Kids would get that. And so you can take that and apply it to all of these claims being made. Here are the steps, once again. Observe a phenomenon. That's just step one. So I've talked to people who try to tell me that astronomy is science. I'm like, what kind of experiments are you doing? And they're like, well, we look through our telescope and we see lights. I'm like, yeah, you're observing stuff. Like, what's next? What are you manipulating to find the cause? Well, we don't have to do that. Yes, you do. For it to be science, you do. Otherwise, you're just observing stuff and making up stories, which is fine. We all do that, right? That's what, and again, we all know people. We have all done this, right? We do it all the time, even with ourselves when we're trying to figure something out. We don't know the cause, so we'll start making up stories about what may have caused it. The local village drunk does it, right? Tells you stories all the time. Let me tell you about why things are the way they are, right? That's what they do too. Well, it's no different than these scientismos that make up stories about things they're seeing. So your alternate hypothesis, that's the key. That means that's the thing you think is causing your phenomenon. Independent, dependent variable, you have to have controls. Your null hypothesis is X doesn't cause Y. So that's what the beauty of the scientific method is. You have two outcomes. Either X causes Y, X doesn't cause Y. That's it. It's qualitative. It's not dealing with statistics or any of that stuff. You do your test or experiment, and then you validate or invalidate your hypothesis. And then that needs to be repeated. So I was going to play this clip from Michio Kaku. He is a quote-unquote theoretical physicist, which is like a married bachelor. Because there's no such thing as theoretical physics. That's just more storytelling. And he says it in this interview, and I wish I could play it. He basically, there's the sum of it, and that's not Michio Kaku, by the way. I'm sure you've seen Michio Kaku on...
You're not going to believe this.
This is him.
In science, we always say that you make observations.
So let me go back. Nobody that I know of in my field, and he says it if you can hear it, understands, and he goes, uses the so-called scientific method. In our field, it's by the seat of your pants, it's leaps of logic, it's guesswork. He's not lying, okay? He's saying it with a straight, funny face, smiling like duper's delight. That's called duper's delight. So when they're smiling at you going, yeah, we're pulling one over on you. That's what they're doing, okay? So they get all these guys on History Channel, and they get them on all these programs, and everybody just goes, ooh, that's so cool, that's science. It's not science, okay? So let's keep going. What isn't scientific? I could make a list so long that people... Astronomy, astrophysics, theoretical physics, epidemiology, cosmology, evolutionary biology, paleontology, archaeology, anthropology, psychology, and the social sciences. Sciences, quote unquote. Mathematics is not science. Technology is not science. Technology can use things from science, but technology itself is not scientific, okay? When you're dealing with man-made things, when you know what caused your effect. You did. You made it. You caused it. You're the man. That's synthetic things and not natural science. So that's a big deal, but the list could go on. And people really get, I hate the term butt hurt, but they get butt hurt about this a lot. If you go tell an archaeologist they're not doing science, they're going to get mad at you. But all you have to ask is, what is your observed natural phenomenon? Not one. You're just looking at stuff. Rocks aren't phenomenon. Bones aren't phenomena. Phenomena is something happening, and then you have to be able to experiment to see what caused it. They can't do that. None of this can do that. The best you can do with a lot of these are observe. And that's fine as long as you're not calling it scientific. Once you call it scientific, but it hasn't gone through the method, by definition, that is pseudoscience. So that's the funny thing is when you see all these people online calling some of us who question things, they'll say, oh, you're just a believer in pseudoscience. They don't even know what that means because by definition, they're engaging in pseudoscience because they call all this science. So that's the funniest part. This is not science. I had a guy who is I think he's doing a master's degree right now in biology. And we started talking about scientific method, and this is what he brought up. He said, this is it. This is the pyramid of evidence. I'm like, yeah, I remember that from medical school. Systematic reviews, randomized controlled trials, cohort studies, case control, blah, blah, blah. Nothing in there is scientific. This is all observation and statistics, not science. This is what most physicians think is science. This is what most academics think is science. It's not. Okay? It's a big deal. I'm not saying these aren't useful, by the way. That's not my point. These are very useful because a lot of times it's the best you can do is just to do some statistics and then you just do a lot of trial and error. And that's okay. This is a quote from Marcia Angel. It is simply no longer possible to believe much of the clinical research that is published or to rely on the judgment of trusted physicians or authoritative medical guidelines. I take no pleasure in this conclusion, which I reached slowly and reluctantly over my 2 decades as an editor of the New England Journal of Medicine. The reason I put this in here is because I see a lot of friends who will start making fun of science and they'll throw out these quotes about, all the journal articles having no science in them. But if you know what science is, that shouldn't be surprising because doing medical research is not really doing science. This is all still true. Most of the things being done, and I think it was John Ioannidis, big guy out of Stanford, came out with a paper saying like 95% of the studies are done, can't be replicated in medicine. Again, but that's not science. So we're talking about kind of drug studies and things like that, interventional studies, which are all well and good. These are things I want people to know, fallacies, because you can spot these a mile away. And I knew these going into med school, and it helped me get through so much. But basically, when you equate science with pseudoscience, right, that's a fallacy. Many Christians don't know some of this stuff. And so there's an issue, a lot of people try to bring up the issues with induction. Induction is trying to derive a general rule from just specific events. And that is a problem, either in science and in the world of statistics. The issue with the scientific method, it's sort of what's called a closed induction, right? Because you're doing that experiment applies, at least the results apply there, so it's a deductive thing, X caused Y. Can you extrapolate that out to the rest of the world? There's some philosophical issues with that. So that's why a lot of people, I'll hear and they'll go, well, science doesn't prove anything anyway. And I'm like, well, then stop using the word. Because they'll go, well, the science tells us blah, blah, blah. And I go, show me a scientific method. And then they go, well, science doesn't prove things. Then why are you talking about it, right? Why are you making positive claims if science doesn't prove anything? So they're kind of living in both worlds there. But in my opinion, at least the scientific method tries. At least you're trying to validate something. Otherwise, you're just telling stories, which is what happens. So fallacies, this is fallacies in general, but this is massive. Two that I see the most common, begging the question, affirming the consequent. If you learn nothing else, learn affirming the consequent. It's my favorite fallacy, and I'll give some examples of it. If P, then Q, Q, therefore P. And I love Jim Bob's comic here because Einstein was good at this. Observe the effect, invent the cause. It's science. And that's what people do, right? You observe something and you declare what caused it. You don't do an experiment. You just declare it. So this was Bertrand Russell, and he was talking about the affirming the consequent logical fallacy. And the reason I included this is it was in one of Gordon Clark's papers. And this, again, it helped me in medical school to see kind of the issues. But I'm not going to read it because this is my example. So if I claim gnomes are trampling my grass every night, and somebody asked for proof, and I gave you a picture of trampled grass as proof, you would think I was insane. That is exactly what happens every single day in academia, okay? A claim is made, and you go, what's your proof for that? And they show you the effect, but they can't show you the cause, okay? Yeah, I know. In gnomes, do they exist, right? First of all, so if, obviously this isn't really a natural phenomenon, but let's just make it like that. If I said this, again, a third grader would go, okay, wait a minute. Show me gnomes are real, first of all, and then show me they're trampling your grass, right? And I'd have to go, no, just look at the grass picture, man. You can't deny that. That's gnome trampling right there. So that's a fun one. I use that one a lot. How about this one? Santa is real. How do you know? Well, there were presents under the tree and cookies were eaten. That's it, right? That's affirming the consequent. If P, then Q, Q, therefore P. If Santa's real, I'll get presents. I got presents, therefore Santa was real. So you got to start spotting this. How about having an illness? That's going to get into some touchy subjects there. I know viruses are real. How do you know? Well, because I had the sniffles. Okay, wait, but show me the cause. Well, I had the sniffles. I was sick, and a few more people were sick at the same time. Wait, that's fallacious. Like, you have to show me the thing that you're claiming is real. Yeah. How about these? You know, and this goes to bacteria stuff. They say, oh, I had pneumonia, and it was caused by that bug in that Petri dish right there. And I go, how do you know that? Well, I said, well, look, I had pneumonia. I'm like, but how did you prove that those bugs caused it? Because those bugs live in everybody every day, and they don't like to talk about that. So I threw this one in there too because this applies to eschatology, right? People, you have your presuppositions, and then they go, oh, man, I heard about another war coming. It must be the end times, right? Same thing. So you got to start being able to pick this stuff apart. But the affirming the consequent logical fallacy is ubiquitous. It's everywhere. And we all tend to do it for things that we have bias about. We can spot it when it's like silly, right? Like the gnomes. But when it comes to some of these like high-tech claims, we don't really question it. Another good example is if I said, if I eat a pizza, I'll be full. I'm full, therefore I must have eaten a pizza. I could have eaten a burger, right? Like, again, it's just easy examples, but you can start spotting these everywhere all the time. So it's fun. Anyway, I'm a broken record, obviously. Definitions and methods matter. So just like proper exegesis versus your traditions and your creeds, if somebody is claiming something is scientific, you have to, number one, know what that term means so you can ask people. And you don't have to be an expert in any of this stuff. You don't have to. The burden of proof is on them making the positive claim. Okay? So if they claim something scientific, you go, what's your phenomenon? And then maybe they have one, and you go, what was the experiment? What's your independent variable? It will blow your mind how many people have no idea what that means. And I'm talking about people who are claiming to be scientists. It is unbelievable. And most of the time I get claims like, well, we just can't do that. It's just too hard. I'm like, then why are you making up stories? Like, you just say you don't know. Be honest. So I get pretty worked up about this stuff. Obviously, get a little hot up here. But it's a big deal because it applies to lots of things that we're taught that are very dogmatic, and a lot of claims made from growing up through public education all the way through college. It just gets worse and worse. All the stuff that's rammed down our throats that we just take for granted is somebody figured it out. And yeah, you got to go back and start digging in and realize that that's not quite true. All right, so I'm going to make this brief and try not to numb your minds. So elephant in the room, right? COVID, yeah, I think everybody's sick of it. I don't even know if I can say the word without somebody coming after me. New virus discovered by Chinese scientists, blah, blah, blah. And that's the current elephant in the room right there, is that we're constantly bombarded by these tiny invisible things that want to kill us, and only if we cover our faces and spray everything down with chemicals will we ever be safe. Oh, and stay away from people and all that stuff. So let me go back and talk about why I got into this. So I guess it was 2020, February maybe. We don't have TV, so we have TV, but we don't have cable or anything, so we don't watch the news. And my mom started talking about some virus and hydroxychloroquine, and we were like, what are you talking about right now? And she's like, yeah, this Chinese virus is coming. And I'm like, what are you smoking? She's like, no, we're going to bring you some hydroxychloroquine. And so they come over to the house, and she won't even come into the house. Like they're at the edge of the garage, and I have to go out there and meet them. And I'm like, who are you people? So Leah and I are going, this is weird. And we start kind of looking at little stuff. And then finally, the news comes out. And I didn't think much of it at first. I mean, I've never been really into all the hype. If the media is pushing it, it's probably garbage. So that already kind of had that going for me. And then I bought the story at first. I'd never looked into virology. I memorized all the stuff in medical school. I'd always just bought it, sadly. And so, but I still knew something was wrong. Something didn't smell right with the way, they were doing things, because I know how the psychopaths work and shutting everything down. And when you can shut the world down with a flick of a switch, that's a problem. There's somebody, that was not an accident. And I started looking into the, was it the thing they'd had in November of that year, just before COVID started, the simulation at Johns Hopkins, right, with a coronavirus and all the things, and you go back and watch it and go, oh, is it Event 201? Yeah, and it's like, well, that's creepy. And then you read the 2010 Rockefeller paper, Operation Lockstep, on a coronavirus that escaped from a Wuhan lab and how they closed the world down and all their plans and what to do is basically just bringing in a technocracy, which sounds kind of like what they're doing now. So all that was kind of kooky, and I was like, that's interesting. But I heard somebody talking about viruses and how they may be getting it wrong all this time. And let me see if I'll go to that in a minute. But it piqued my interest, so I started looking into this whole topic more, and I spent the last 2 years, I don't know how many hundreds of papers I've read, and Leah can attest to it. It became an obsession, because that's what it takes sometimes to really pull apart a narrative, is you have to go back and actually read the papers and then track the references back, and you have to track those references back to the original papers. We're talking like late 1800s, early 1900s stuff. And at this point, it's old hat. But I wanted to talk real quick about beliefs about disease before we go on to this elephant in the room. I mentioned some of this earlier today, the miasma theory, bad air. This whole germ theory comes from this Fracastoro. He was serving the Pope in the 1500s. He came up with this idea that there were little seeds of disease and that they spread by different routes. So the seeds, it became the germ, like germination for seeds. Very atomistic, very materialistic, right? That everything's particles and out to get us. And then germ theory came along, late 1800s, still the mainstream view that we all talk about and believe. These disagreements, though, even about this was a long time ago against Philo, and this was sort of against the atomists. He says there cannot be a new disease without a cause, for this would introduce it into the world, contrary to natural law, coming to be from non-being. To find a new cause for disease would be hard, and blah, blah, blah. Anyway, the gist is people have been debating this stuff for a long time. So germ theory in a nutshell, it's not a scientific theory, okay? That's something I wanted to talk about a minute ago. A scientific theory comes after you validate your alternate hypothesis. After you've proven something causes, that's when a theory is formed. So all these guys going and saying, I have a theory, that's colloquial. That just means a conjecture. Theory in science comes at the end of experiment. That's a big deal. Other thing I wanted to say, scientific laws are not scientific. Laws are descriptions. Science deals in cause and effect. So it's a misnomer to call them scientific laws. So when we talk about the law of thermodynamics, that's a descriptor of things that happen always, or so they assume. But that's not, nobody knows the cause, right? Nobody knows the cause of entropy. If you could validate the experiment, you would be able to remove the cause and vary it. Therefore, it wouldn't be a law anymore because you could stop it from happening. If it just happens always, it's a description. Anyway, germ theory is this idea that there's infections, contagious diseases, and various other conditions that result from the action of microorganisms. And we all buy this and believe it. And I did too, until a couple years ago. So that was a definition. Here were some early guys that were duking this out. I'm sure everybody's heard of Louis Pasteur, pasteurization, rabies vaccine, all that good stuff. His rival was Antoine Béchamp. There's a good book on this. There's a couple, actually, I'd encourage you guys to look into if you're ever curious. Pasteur was a fraud. I think it was his nephew eventually released his diaries, and those were published. It's pretty fascinating to go through and read what he actually did and a lot of his quote-unquote experiments. Béchamp was the father of what they call now terrain theory, and some of you people may have heard of terrain theory. I'm not sure. I don't like that word because, again, theory entails scientific theory, and terrain theory is more just the holistic view of the state, the natural health of your body determines your disease states, right? It's the soil, right? Your internal soil determines how you function. And it actually kind of makes sense because we apply that to the real world too. How's your soil in your garden, right? So that's sort of the big one. But basically, Béchamp, and I don't have to read that to you. So they were doing stuff on fermentation, really weird things. Pasteur was trying to prove spontaneous generation. He couldn't. And Béchamp showed it wasn't possible, it wasn't happening, but that these other little things in the air could ferment sugar. He'd eventually discover what he called microzyma, these tiny particles, and he made some outlandish claims that these are the basic building blocks of life. So there's pseudoscience in all these different areas. That's why you have to be careful with rival beliefs. But basically, he's not the only one that showed this. These tiny particles would morph at will, as needed, depending on the environment, into bacteria, and then into yeast forms. And this was seen later with Gaston Naessens, and there were several other guys, Enderlein, basically talking about what's called pleomorphism, which is completely written off in modern medicine. They do not accept that bacteria are pleomorphic, meaning they can change forms based on how they need. We assume there's one type of bacteria, within a family there could be a few, but then there's all these hundreds of different specific types. Interestingly, in the early 1900s, the U.S. Department of Agriculture wrote papers on pleomorphism, claiming it was real. They were watching bacilli, rods, turn into cocci, little balls of bacteria, and all this. That's a big deal because that shows that these things are responding to our environment. And I don't want to get into the bacteria stuff because this is more about COVID and sort of a bigger picture. But bacteria aren't the little demons that we think they are. We live with them, and this is becoming more accepted as far as like the microbiome. I'm sure people have heard about. We have all these bacteria in our gut. They're in our mouth. They're everywhere. They're just hanging out. And what happened was they started finding them associated with certain disease processes, and they just again asserted that they caused this instead of maybe they're the result, right? Maybe they're the effect. Maybe they're there eating dead tissue just like they do everywhere else in nature. But that didn't fit the business model, right? So we need antibiotics, we need drugs to kill these things. So Béchamp was against a lot of that. He kind of called out Pasteur on some of his anthrax fraud. I encourage people to look into it if they want to. I don't want to read all this. I just want to kind of get through it. But there's some good quotes in there. Koch was another one, father of germ theory. He supposedly proved tuberculosis was caused by bacteria. There are several books on this from the early 1900s that completely debunk that. Plenty of people with TB, in fact, most of them never got TB around all the other TB patients. They don't find the tuberculous bacteria in early stages of the disease at all. They form later. They could give animals the TB nodules by literally injecting them with almost any foreign matter. You could inject them with latex and they would form tuberculous lesions and through their whole body. So you're probably dealing with some kind of exposure at the time, whether a lot of people working in mines and all this stuff. So these are things that just aren't looked at, right? Like we talked about this morning, like environmental toxins and all this, nutritional deficiencies. It's just not really thought about because we get to blame the bug because it's easy to find them, right? So they're kind of a scapegoat. This is interesting. Koch's postulates, he came up with these, which are funny because they never really worked. It's basically a modification of the scientific method trying to prove that a microorganism, bacteria in this case, causes disease. So the microorganism must be found in abundance in all organisms suffering from disease, but should not be found in healthy organisms. Well, guess what? You find most of these things in healthy and unhealthy people. So that's where they came up with the whole asymptomatic carrier story. So some people just carry these around and they're just chilling and they're not hurting anybody. And then one day they go rogue and they just attack you. And nobody can explain that. So anyway, they can't, for virology, they can't really apply these because I'll tell you in a minute. So rabbit trail, again, this is COVID. It's what they claim to be COVID, right? They go, oh, we got pictures? Well, it must be true, right? I mean, I got a pixel in the sky on my telescope. That must be a giant black hole ready to eat us. It has to be, believe me. So that's what's going on here is point and declare. So when I started looking into this, I saw a guy talking about this. He goes, are viruses really exosomes? And I thought, what the heck's an exosome? I don't know. I'd heard the term before. Well, basically exosomes are just little particles that they see on these electron microscope images that are ubiquitous in people. They are especially prevalent when you break down tissue, cells. So when you have diseased cells, you see these little particles over here. I don't know how to use this pointer. Right here. These are exosomes. This is claimed to be COVID. Right here, these. Okay? They look the same. So that piqued my interest. And I was like, man, I don't know. I don't know. I got to start looking into this. So what I did, I'll go back to that in a minute. I went and read the first published paper on COVID from China. And I saw immediately the issue in the methods section. When you always go to the methods, in my opinion, if you're going to read a paper and see what they actually did. And I'll go into that in a minute, but I definitely saw some red flags. And so I want to talk about that in just a second. But real quickly, people always there's another aspect of this with contagion, right? Because there's two different issues here. There's contagion, and then there's what could possibly be causing contagion. And those aren't necessarily the same thing. So contagion study, best one ever done, 3 of them, 1918, 1919. This was with the Spanish flu. Okay, supposedly the most deadly, contagious thing ever to exist. They took 100 volunteers, and each time, these were Navy guys, they were prisoners, so they weren't really volunteers. They got volunteered. And they were exposed to actively dying people in the wards with Spanish flu. They had them talk to each other face-to-face for 5 minutes. They had them inhale while the other one exhaled. They took fluids from the sick people, put it in their eyes, their nose, their mouth. Things they would never do today because it's not ethical, right? Nobody got sick, not a single person. And you can read these. The book is free on Google Books. It'll blow your mind. And that was a big eye-opener for me because you think they're going to share that in med school? They're not going to share that with you. There are paper after paper like this, okay? When dealing with flus and colds, we still to this day, they're talking about influenza and we don't really know what causes it. We don't know why people get it. You know, they got people on ships for months that are never sick, and all of a sudden they got an influenza outbreak. I've seen the stupidest things where they have an influenza outbreak in these random villages that are way apart. No contagion could account for it, to the point where they said it must be viruses falling from space. I'm not making that up, okay? They just fall down on you. Anyway, the contagion studies are fascinating, especially when it comes to colds and things like that. They just can't really do it. So what they did back in the day, and they still do it to this day, instead of exposing people or animals to each other that are sick to see what happens, they just take diseased junk and inject it into animals, and the animals shockingly get sick because you're not supposed to inject diseased things into other people. So that's not, again, scientific, because the scientific part would be, what is the supposed natural route of contagion in the first place? That's what you would have to test in the experiment, which is what they actually did here. They actually did the supposed natural route, which is exposing people face to face, taking their fluids, exposing them to that. They're not injecting them with stuff because that's not natural. And I mean, unless you're talking about a trauma. Anyway, that one it's really kind of gross. And they did this with animals too. They did it with horses. Nobody got sick, nothing. And so that was interesting. This was his, I'll have to share this with you guys. Y'all can read the final conclusions. After all their negative results, he said, despite our negative results, it is nevertheless probable that the disease is transmitted by the discharges from the mouth and the nose. Nobody got sick. I mean, it's just unbelievable that they have to cling on to that belief. So again, I've got studies saved. I've got a folder if anybody wants it. Chickenpox, same thing. Couldn't transmit it. So what did they start doing? They started taking pustules of chickenpox. They would take animals, they'd shave them, they'd cut lines into their bellies, they'd smear all the crap from the pustules into them, and then they'd get a skin reaction, shocker, and go, yep, we transmitted it. No, you didn't. That's not how it's transmitted in nature, and just because you get a skin lesion from cut open wounds does not mean you replicated the disease. So there are paper after paper where they actually tried doing it with humans, because again, they actually used to do this stuff, and they just couldn't do it. People weren't getting sick. They did it with measles. I've got papers on scarlet fever where they were taken because they thought it was a bacteria in the throat, and they'd rub it on monkeys' tonsils and people's tonsils. Nobody gets sick. So we just got to start injecting it. That's what they do to this day, which is it's fraudulent and it's frustrating. But I can send you guys those papers. So I wanted to talk about virology real quick because that's more the elephant in the room. I think bacteria can probably be a problem. Let's say that they are there just cleaning up diseased tissue. Well, guess what? They make waste products, and those waste products build up in the blood, and so there could be a massive reaction. It's not them that caused the initial problem, though, but they're breaking down waste. They're making their own waste. If you're pretty toxic, that could be a big deal. So that's not the same thing as the contagion model, however. So this is the current definition of viruses. Any of a large group of submicroscopic infectious agents that are usually regarded as non-living, extremely complex molecules that typically contain a protein coat surrounding RNA or DNA core, but no semipermeable membrane, capable of growth and multiplication only in living cells, and that cause various important diseases in humans, animals, and plants. That's kind of the gist of it. And we all use the word, it's kind of growing up when the doctor can't figure out what's wrong with you. Oh, it must be a virus, right? That's we all know it. Here's some antibiotics anyway, but yeah, it's a virus. So they still do that today. So these are claimed to be viruses like Ebola. I mean, we're all scared of Ebola. Everybody's seen Outbreak, those movies. HIV, man, that's a big one, right? H1N1, all these, MERS, SARS, COVID. So what is the issue? There's no scientific evidence for virus theory, okay? So let's go back to the scientific method real quick, just because I want, if anything, I want y'all to understand that. I don't want you to believe me on this. I want you to understand the method, because it's claimed viruses are proven scientifically. That means you got a natural phenomenon. Okay, great, we got sick people. That also means you've taken the supposed virus, your independent variable, you've manipulated it and varied it in an experiment to prove it causes a disease. Well, that's the problem, because they don't find these things in people. They never have. They don't actually see them in humans. They were never identified in nature to begin with to even go, I wonder if that's causing the disease. Because see, in science, your independent variable, number one, has to be real. It has to exist. You can't manipulate and vary something that doesn't exist. So that's a big deal. So what did they do to get around this? What you have to go back before the common definition now. They had a different definition of virology and viruses until the 1950s. They used to think they were replicating proteins and not this RNA, DNA stuff. Before that, virus was just used as a colloquial term for poison or a toxin. So you can find studies on bacteria in the 1800s where they interchanged the word the infection or the bacteria with the virus, the virus of whatever bacteria. So you have to be careful with all these and understand how they've changed the language over the years as well. It's pretty fascinating. But early on, they did the same stuff now, but early on they would basically use what are called tissue cultures or animals. But they would take and it's terrible, they would take tracheas from aborted infants, and then they would take diseased tissue from someone with this disease. They would inoculate the tissue cultures with the diseased tissue. Something would happen, the tissue would break down, which it's already breaking down, and they would claim this proves virus. So if y'all understand what we talked about earlier with affirming the consequent logical fallacy, that is that's a big one, okay? That's huge, because you can't claim it's proof of something never proven to be real in the first place, okay? I can't just make it up and say Goopel snurkledurks are causing this. I see my effect, therefore this proves that those are out there getting you. You can't do that. You actually have to use the thing and see if it's causing your effect. So basically they injected animals with putrefied matter and they made them sick. Big shocker. So what they call virus isolation now, you'll see this everywhere, because I was kind of duped by this at first because they use this in all their headlines. Virus isolated. What does isolate mean? To separate from another substance so as to obtain in a pure or free state. How can you isolate something that's never been proven to exist? Okay? And I'm serious, you guys you'll think I'm crazy. I have searched every paper I could find. I just searched every coronavirus paper, because once you read one, you realize they're already begging the question that viruses exist. So they do their little cell culture stuff. So let's take with COVID what they did. They took lung fluid from a sick person that had an atypical pneumonia. They took the lung fluid. Lung fluid has all kinds of nasty stuff in it. They spun it down a little bit. They put it into I think for the first study, it was actually liver cancer cell line. okay, in a petri dish, liver cancer cells, which are already abnormal and sickly and dying. And then they get what's called the cytopathic effect, which just means cell breakdown. And that's claimed to be proof of the virus and isolation of the virus. And I saw that, the first paper I read, and I was like, okay, that's a fallacy, but surely they've got to have it somewhere that was proven that that effect can only be caused by a virus, right? Surely. And the other thing was they claimed that they sequenced the genome of it, and it was 87% similar to SARS-CoV-1. So I reached out to a guy who was talking about this stuff online. I kind of, just was like, okay, we'll look into what you're saying. I messaged him, and I was like, okay, I see the problem with the first paper, but what about this genetic stuff? He goes, go read the SARS-CoV-1 paper. I was like, oh yeah, that's probably a good idea. So I go and read the SARS-CoV-1 paper. Well, guess what? They did the same thing. And I was like, okay, so they don't have one here either. So then you have to track back every paper until the originals, and you find there was never anything there. So that's what kind of got my interest piqued. And so I thought, well, because there were a lot of people that, even like prominent people, were coming out and saying, yeah, SARS-CoV-2 has not been proven to be isolated. But these were still people that were believers in all these other viruses. So I thought, well, let me go read those other virus papers, because they must have the real deal. They must know how to truly isolate a virus, versus these papers. No. Every virus paper is the same. They all use the same method. There's no difference across the board at all. And this has been done from day one. And so, again, you have to prove the existence of something first before you can even claim it causes anything. You've got to find it. So we've talked to guys, and I've got a picture of that, of some of their responses, but basically the current method goes back to Enders, who won the Nobel Prize in 1954 for this method. That's why it's still used today. It's the gold standard. You take fluid from a host, blood, fecal matter, throat washings. He added them to milk, so he took some stuff and put it in milk. That's a good start. Spin it down. You add it to abnormal aneuploid cell lines, meaning they've got like 80 chromosomes compared to our normal set. They used monkey kidney cells, which is still used today. That's a big one. That's a favorite. They add antibiotics to this culture, not to mention the antibiotics are toxic to kidney cells, nephrotoxic. They add some fetal calf serum. They wait for a few days. If the cells start to break down, they call it the cytopathic effect, and that's claimed to be proof of a virus. And this is done today, just like it was in 1954. It is a begging the question fallacy, because virus has never been proven in the first place to cause cytopathic effect. Okay, so they're not only doing an affirming the consequent fallacy, right? So if I could at least use that fallacy and go, if it rains, my car will be wet. My car's wet, therefore it must have rained. That's fallacious, but at least I know rain is real, okay? You can't even do that here. So they're actually begging the question, meaning they're assuming the thing they're supposed to be proving in the first place, and then they're flipping it backwards, doing the affirming the consequent fallacy. So that's what I really wanted to get across, because you can spot this all day, every day. This was his method, and it's hard to see this, but basically, yeah, you take stuff from the mouth, you put it in a cell culture, you do all these steps, and they use language to make you think they actually got what they claim. They'll say, we took the isolate, and back in the early days, everything was an isolate. It was like, we took the virus, and so they would from somebody with a cold, they'd take snot, and they'd say, we isolated the virus from the person. They're already just assuming this, right, that there's a virus there. And then they would do a tissue culture, and then they'd say it again, now we isolated the virus this way. And what they do is they do this over and over and over, either in animals or cell lines, where they get breakdown, they take the breakdown products, they introduce it into another cell line, they get that one to break down, and they do it over and over, and they call that passaging the virus. And they do this in animals too. They'll inject them, and it's disgusting. They'll literally take the nastiest stuff you can imagine, they'll inject it into the peritoneal cavity, they'll inject it into their testicles. Their testicles will literally start to die. They'll take the testicles, grind them up, and then do it again to another animal, and another animal, over and over, 18 times, and go, we passaged the virus 18 times. It's literally disgusting. And I can't believe it ever passed muster. So this is what Enders claimed was proof of a virus, when the cells go from this to this. The problem with Enders' paper in 1954, he got the exact same effect without adding anything to his sample. And he admits this at the end. So cytopathic effect, this breakdown, occurred just from the procedure itself. So you would think he wouldn't win a Nobel Prize for that, right? So Stefan Lanka is a guy that's been calling out this stuff for a while. I had never heard of him. So he actually won a trial in Germany from the Supreme Court because he was a virologist in the beginning of his career. And when HIV came around, he started seeing some of the tragic way people were treated, and he started calling into question some of this stuff, and he started looking into it. And you can find his videos on YouTube. But anyway, he challenged several scientists, virologists in Germany about the existence of prove there's a measles virus. He won. German Supreme Court. You think that was ever made popular in the news media? Anybody hear about that? No. So he's been involved, and what he did in this trial, and he's done it now with COVID, he's still involved doing this, he took the exact same methods they do without any sample from a person and got the same effect and showed you it's the process that they're doing that's damaging the cells. It's nothing to do with an entity never proven to exist. And so, you know, that's a problem. Whether anything will come of this or not, I don't think so. I think there's too much dogma. There's too much money involved because so much is built on this belief. So anyway, that was his results. But these are his most recent ones. But you can see he didn't add anything to the samples, and he still got them to break down. He added basically like yeast RNA, and he added just antibiotics, and he got the same effects. And that's a big deal. So I wanted people to hear this because Kary Mullis, I'm sure you guys have all heard about the PCR test with COVID and all this stuff. Kary Mullis was the inventor of the PCR test. Kary Mullis was one of also the biggest dissidents against HIV, which is interesting. And he went on a tear for them using his test to quote unquote find HIV because that's not what it was doing. So in this clip, which you're not going to be able to hear, Mullis basically, and you can find these online, it's fascinating. He was an interesting guy. Basically, what he did that got the ball rolling with this is kind of like what I've done now. He was chosen to write a paper on HIV. And he's like, okay, to start my paper, I'm going to write HIV is the probable cause of AIDS. And he stopped and he thought, wait a minute, I need a reference for that. I need a paper that proves that. Like, I need validation, right, which is what we're supposed to have. He couldn't find it. So he starts going to all the big name guys. He's like, where's the paper? I need a paper that shows HIV is the cause of AIDS. And they'd give him something on some simian leukemia thing. He's like, that's not what I need. I need HIV. And in the quote here, he's like, he kind of beside himself. And he's going, and I finally figured out they don't have it. They don't know. He's like, they don't have a clue. And it's true because it's not there. And so this it's the same with all of these. And it's very frustrating when you start looking into it to see the deception. And I don't want to call it a deception. It's a false paradigm, okay? It's a belief system because they made up this story a long time ago in the 1800s, and they just assumed it was true. And so now they're claiming all these effects are proof of cause when the cause has never been validated. And that's why I said this morning, and I'll say it again, is that you have to disassociate effects from causes. You don't get to just point to an effect as proof of your cause if you have never validated that. You can't just make it up. It's a big deal. And so anyway, I've already talked about all this was done with COVID. These monkey kidney cells are inoculated. This was done with CoV-2. So then people go, well, what about the electron microscope pictures? That's proof. Well, first of all, pictures aren't proof of any cause and effect relationship. Pictures are pictures. I could show that to 1,000 people, and they would interpret it 1,000 different ways. So this is where presuppositionalism comes in and understanding that we do not learn things by just looking at things. We already have knowledge, and we interpret things by the knowledge that we have. So if you believe those are, let's say those are little popcorn balls on Mars, Sure, I could do that. Or I could tell you, no, that's supposed to be the polio virus, right? I could make it up. And this is the same thing we see with like art, right? You ask somebody to interpret a painting, you're going to get 100 different interpretations because if you don't know what the author intended, you're going to just make up a story. That's what they do here, okay? Not to mention the problems with electron microscopes, which actually destroy the tissue. That's a big problem too. But this was claimed to be polio. These are problems with electron microscopy. I'm not going to read this, but Harold Hillman was a biologist who called out all the mainstream guys over and over and over again, and nobody would debate him. He's brilliant. You can find his videos on YouTube. He's dead now. He talked about so many issues with these things, what you do to these samples just to get them in an electron microscope. Basically, you're probably seeing mostly artifacts in there. because the way that these are done damages the cells in the tissue so bad. It's all dead tissue. You don't have a clue what you're looking at. And I knew this in med school. I remember it. I remember seeing things they were telling me, this is this and this does that. I'm going, there's no way they know that. They have no idea that's what that does. They just point and declare. And it's very frustrating. So what if I told you, so I could spin a story real quick because people, I've done this, I pulled this trick on people on Facebook. I go, man, yeah, I was sick or somebody was sick and I found this paper and they showed all these viruses in them and I was like, look at all these, look at this, guys, they're everywhere. These are directly from patients. They're like, yeah, viruses are real. I'm like, yeah, I'm just kidding. These are exosomes from human tears, okay? These are particles they find in human tears. Now, the funniest part is in people that are supposed to be dying of viruses, they can't find any of these in the people, okay? These are supposed to be millions and millions exploding from our cells, killing us. Doesn't happen. So a couple of the guys that I'm involved with, they debated a Yale virologist about this. And they asked him, if we take a sample from a sick COVID patient, can we find the virus in them? No. Why not? There's not enough. If we pool 10 samples, could we see the virus then? No, not enough. What about 10,000? No. Once they got to 100,000, the guy stopped answering questions. Okay, and I'm not making this up. It's tragically, or it's comedic. It's tragic. That this should be everywhere in people that are supposedly infested with viruses. You should see particles galore. You should be able to take those particles directly from a human and figure out if they're actually causing anything at all. That just doesn't happen. So the other issue is, in these cell cultures, all these particles are also made, but they don't account for them. So they just pick whatever particle they want from this little cell culture and go, that's a virus. And I want to go, how do you know it's not one of these? How do you know it's not an exosome? They got papers from virology and exosome people going, yeah, we can't really distinguish the two. Well, that's crazy. So how do you know one even exists in the first place? It's a big deal. So this was published this year. These are samples from people with positive COVID PCR tests and negative. They find the same particles in both. Okay? Same things they're claiming are COVID, they're in everybody. But they're just a few of them. So that's a problem. And that's mentioned in a lot of these papers. So these are the responses I've gotten. I was on Twitter for a while, which I don't recommend ever going on Twitter. But I wanted to and I got involved with some 50-person thread with virologists and microbiologists trying to kind of just ask questions. I got called a lot of names. I never got a single scientific paper for viruses. Not because, number one, they don't know what science means, because I would ask them, can you give me scientific validation? And then they'd throw all the standard papers. I'm like, no, I've already read those. I know. That's my issue. I know those papers. I need an experiment. I need an independent variable. I need to see where this was ever done. And then I get a lot of responses like, oh, science doesn't prove things anyway. And I'm like, okay, whatever. But this was a fun one. The virus is too weak to isolate or purify directly from the fluids. That's insane because they're supposed to be killing us. And if you can't ever find one in a person, how do you know they exist in the first place? Okay? Again, to form a hypothesis, I see X, I think it's causing Y. Where were these ever seen for anyone to ever say, I wonder if that's causing this disease? You have to have that. You can't find it. Doesn't exist. Next one, you're not a virologist, you don't get to determine what isolation is. That's not an argument at all. That's just ad hominem. So bypass that one. Virus needs a host in order to replicate, so that's why we use the cell culture. What do you think the human body is? It's a giant cell culture. Okay? Should be the best one we have, considering they're supposed to be killing us. And then the fourth, there's not enough virus present in the fluids, which is kind of the same as the first one. So they're all really bad answers. I mean, these are from top people. That's the best we got. When I'm not getting papers, I'm getting this stuff. So that has been really my big red flag the past 2 years looking into this. And I promise you guys, I have looked as hard as I can, and it's a problem. And it's weird when you start coming across some of these guys who are sort of mainstream. Like there was a guy for HIV called Peter Duesberg. He was big, like cancer researcher. Came out saying that HIV was not the cause of AIDS, but he still believed there was a thing called HIV. And then there's people that came out and said, well, there's really no such thing as HIV, but all these other viruses exist. Well, that's a problem because every single paper is done the same way, no matter the virus, right? So if SARS-CoV-2 is bunk, like some of these people are claiming, it applies to all the rest because it's the same stuff. It's the same methods every time. You have to read them to know that, but it really is, it's a little mind-blowing and scary when you realize it. I want to talk about testing real quick because that's been the story of the last 2 years because that's what we've had is a pandemic of testing. You can't test for something not proven to exist, okay? So my analogy would be I claim that every night unicorns are invading my yard and I take some microphones and set them up around my yard and I just record sounds. And then the next day I splice all the sounds together. I think what a unicorn mating call might sound like, and then I whittle it down and get it, and I make a test that seeks for that sound wave form. That's my test for finding mating unicorns. That's what they did with PCR, okay? So they take a crap ton of genetic material. I mean, we're talking lung samples, just non-purified stuff, and they basically already have a template, and so they cut out everything they don't want. They build the template in a computer, and they make a test based on that. They made the PCR test for SARS-CoV-1 before any papers were ever even done. I mean, no research at all. And so the PCR finally started getting called out. Even like doctors in my town who still believe all this, they finally understood the PCR was nonsense. Well, then they went with we got to do the rapid test. You got to do the antigen test. Again, there's no antigen test because you're not detecting the thing you're thinking that you are, right? So the big thing now is this spike protein. And they're like, oh, well, the spike. Spike from what, right? Where did you ever get a spike from a virus? There's no virus. So whatever this protein is, you're probably just finding it in people that are sick, sometimes not, and you're just getting lots of positives and negatives, and you're telling people they have something that they don't. And they did this with HIV. You can have a positive HIV test for 70 different things. You know how many lives have been ruined from that? That's evil, and that's stuff Christians should know. You can go to Africa, you don't need a test. There's no HIV test anyway that's accurate, but you don't even need a test in Africa. You need to have weight loss for a few days and some diarrhea or a cough, and you have AIDS in Africa. And then you get put on horrible toxic medications. That's how you get the numbers that they got, and that's how you get philanthropic organizations to go do good things that aren't good. So it's more heinous than people, I think, care to actually believe, because for some reason people don't understand the depravity of man. But these organizations are sick, and most people aren't in on this, okay? Again, this is all, we all believe it, right? It's just belief system. Until you go knocking down everything and trying to deconstruct it and going, I need the validation, you're lost, with this stuff. And it's easy to, I guess, to buy it. But enough people have called this out. I never knew there was a huge cohort of HIV questioners that were all in the scientific community. I never knew that. We didn't learn that in med school. Very smart people that were calling it out, going, we need evidence, and then people just dismissed them, called them names, of course, because that's all they can do is call names. They can't actually just debate and have arguments. And that, to me, is a red flag. If you can't actually support your claims, there's a problem there. And we all have to start doing that with people when they start making these positive claims. You ask them, how do you know that? How did you verify that? Don't give me a story, don't give me a headline, don't throw articles at me. When you make a claim and then you use somebody else's argument, that argument becomes your argument, and you have to back it up. And people need to understand that. And so I don't make any positive claims here. I don't have a clue what all makes us ill. There's probably a million things we don't even know. But I can tell you right now that what they're telling you about this stuff has never been proven true. And I see people who kind of like to waver, and they're like, well, just because it's not proven true doesn't mean it's not real. Okay, that's a pretty big burden of proof, though, that you have, right? You don't just get to make it up. And then it's one thing to have conventions, and let's say, well, this is just a model of disease. We don't really know if these are real. That's fine if you're not locking people down and jabbing them with things they don't want, masking them and taking them away from family members. That's when it becomes a problem. When your models turn into a religion that is tyrannical, that's a problem. And Christians should have been at the forefront of this But I think because we're so, and that's the bigger point of this talk, it's not about virology. This is about Christians need to be able to call out all this stuff that's rammed down our throats from high on academia, from white coats and all these people with degrees. I promise you they don't know near as much. I'm not saying all of them, but the majority of them, they don't actually know what science is, and they don't know what they're talking about with a lot of this stuff. A lot of it is theories, not scientific theories, just theories and models to try to help explain something. And you could go into other topics about this, quantum physics, and you could go into even the models of the molecules that nobody's ever seen, right? Like, why is carbon number 666? I don't know. It seems kind of convenient. Number of man, carbon, man, I don't know. So there's some interesting stuff with that. You start looking into a lot of the occult stuff, and you realize that a lot of these guys had a lot of ties to academia and stuff in the past. But again, that stuff is fun on the side. It's not important. The main thing is, how do you know what you know? Why do you believe this expert over that expert? That's the most important thing. So, and the other thing I want to talk about the PCR, even at the very beginning, they admitted this. There was no gold standard for the PCR. You know what that means? So like if I had developed a cancer test without any tissue specimen to begin with and started running tests on you guys telling you had cancer, I would have been put in jail. That's fraud. And that's what they did. You made a PCR test with no sample. And this is still admitted by the FDA now in their most recent paper. Right here. Blah, 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 real-time PCR were determined in limited detection studies. Since no quantified virus isolates were available at the time the test was developed and this study conducted, assays designed for detection were tested with characterized stocks of in vitro transcribed full-length RNA. What that means is they made up the sequence in a computer and made a test against it based on nothing at all in reality. This is done in genomics every day, and I don't want to go down the genomics rabbit trail, but I promise you there's a lot of stuff on that in that subject that's probably not what we're being told. And that bothers me because I sucked all that stuff up. I love those topics in medical school and pre-med. It doesn't mean a lot of these effects aren't real, okay? That's why I don't want people to go, oh, you don't believe sickness is real. You don't believe in measles. It's like, what? Just because I'm telling you that the cause is not proven doesn't mean the effect isn't real. It's the story behind it that has to be validated. So you can't, my mom did that to me when we started talking about this. She's like, you mean people don't get sick? I'm like, what? Like, how does that even enter your head? I mean, I'm a freaking doctor. It drives me nuts. So anyway, I don't want to belabor this. Big picture, this is the bigger picture. Claiming effects as proof of cause is not scientific, okay? We should be Bereans in all of our life, okay? You apply the same principles when somebody starts making claims about Scripture. You go, show me that. Show me that in Scripture. How do you know that? And I know there's gray areas and there's stuff, but a lot of this stuff, when it comes to science, it's so hyper-specific. You can nail people on it. And I'm not telling you to go around picking fights with people. You can do it in subtle ways. But you will be amazed when people start claiming science and you start asking them about their independent variable and their experiment and their phenomenon. They're like, what are you talking about? I'm like, well, you're talking about science. I thought we were talking about the same thing here, you know? They don't get it. And it's eye-opening. So always ask, how do I know this? I think with anything, are these claims validated and how? So models, again, models are great unless they start locking down the world. You know, people got models of visible light spectrum as if it's a wave. Nobody knows what light is. Nobody. They say, oh, it's photons. And then everybody else says, these other guys say, oh, it's waves. It's like, you can't study light. You don't see light. I don't see light. I see things lit up. You don't see light. So that's a whole big can of worms. And I think there's some things we're not meant to know, I'll be honest with you. And there are limits to this stuff. I don't, as a non-empiricist, you have to start looking and going, can I ever really discover cause and effect at all with the scientific method? I don't know. That's a philosophical issue. Gordon Clark would say, no, you can't figure out the cause of anything. I think there are probably macro things you can figure out, but everything leads to an infinite regress. Well, what caused that? Well, what caused that? Well, guess what? God caused it all. But there are proximate and ultimate causes, right? And I do think there are bigger picture things you can kind of figure out. But models are great until they start ruining people's lives and become religion. And so that's kind of what the issue I've seen the last couple years. This was, I thought, a cool quote from a philosopher of science. On closer analysis, we even find that science knows no bare facts at all. That is very much in line with Christianity, okay? There are no brute facts. We interpret the world based on our presuppositions, okay? So as a biblicist, we interpret things based on Scripture because that's where we get our truth. And this applies everywhere. So these people saying, I can just look at something and interpret it. No, you don't. You have to already have knowledge about things to interpret them. So knows no bare facts at all, but that the facts that enter our knowledge are already viewed in a certain way and are therefore essentially ideational. This being the case, the history of science will be as complex, chaotic, full of mistakes, and entertaining as the ideas it contains. And these ideas in turn will be as complex, chaotic, full of mistakes, and entertaining as are the minds of those that invented them. I think he gets science wrong here. Most philosophers of science, believe it or not, never talk about the scientific method. They always talk about induction and correlation and statistics. Gordon Clark did the same thing, which was frustrating. I read his book, Philosophy of Science and Belief in God. Almost everything he talked about in the book had nothing to do with actual science. That's the bigger problem I'm seeing, is that until people actually understand what science is, Christians especially are going to belittle science because they're mistaking pseudoscience for science. And that's a big problem too, because I do think there's probably a place for the scientific method. It's very logical, it's very basic, we all understand it. Even the principles apply to non-scientific things, like tinkering to figure out what's broken on a car, right? It's just process elimination, trial and error, this causes this and this. It's the same principles, it's just you're trying to apply it to the natural world. So I think that's important that people, because I do see a lot of Christians especially get caught up in bashing science because they equate it with all the nonsense, not realizing there is a difference. But real science, I don't even know if it's being done anymore. I wanted to play this pretty bad. It's Francis Schaeffer. And he's basically talking about how you don't need conspiracies for this stuff to happen. You just need a media. That's all you need. You need storytellers. And once they craft the narrative and you have a willing, receptive public, there's no conspirators needed. And I don't think this was some grand conspiracy. I'm sure there are people, when you start realizing that they're doing these pseudo-epidemic trainings and all this stuff, Event 201, they've got one for 2025 already called SPARS instead of SARS, S-P-A-R-S, SPARS 25. I'm sure something will come, But we have to be on alert when that stuff happens because it's going to happen again. It is amazing how they can recycle these stories over and over again. They did it with Zika virus, right? Little kids being born with anencephaly. Yeah, that's not a virus doing that. That's probably the neurotoxic pesticides they're spraying around in those areas. But that's another thing is these quote-unquote outbreaks are often cover-ups for toxic exposures, chemical spills, chemical exposures, all kinds of stuff. It's just interesting. I've got papers linking. They showed arsenic can cause chicken pox. It's just like, it's amazing when you actually dig deep on some of these things, but you have to go find it. And I don't expect everybody to do that, but it's kind of driven me a little bit crazy in the past few years. So this is one, I just added this because a friend of mine on Facebook, he's in South Africa. His dad was a preacher, he's Reformed, really good guy, and he's a Christian, and I've got him kind of looking into all this stuff. And he always tags me on Facebook with quotes that he finds. And I thought this was an interesting one. It's long, but I thought it was good. The absurdity of forsaking Christianity in the sciences while maintaining it in the church is often the result of cowardice and often due to an implicit acceptance of the supremacy of unbelief. Those who adhere to and practice this believe they have found the best way to be counted among the so-called civilized and enlightened people of our age, yet without forsaking the faith. Therefore, many of the fiercest proponents of godless philosophies themselves, often without realizing their consequences, have been Christians because they seek exculpation for their adherence to the gospel by means of their scientific unbelief. In this way, Christians are often swept away by anti-Christian prejudice, but those who could have previously been excused because they could not see the full implications of the spirit of this age are now without excuse. The Christian worldview has been vindicated by the fruitlessness and depravity of the anti-Christian view. That divine revelation should reign supreme in the sciences is evidenced by the confusion and violence that now characterize the life of the misled and agonized nations which have forsaken Christian principles. Basically, most Christians have given in to secularism, and they suck up all the secular nonsense, and instead of that, Christians should be at the forefront. I'm not saying doing science, but we should be intelligent, just like we are, like I say, in the Scriptures, being Bereans in Scriptures, be it in every aspect of life. Learn what these terms mean so that you can have conversations with other people. Because the normies who are going out there talking about science, the lady within Science We Trust on her shirt, she's not going to have a clue what she's talking about. But other people will, people that have degrees after their name, and they start spouting science, and then you can just kind of pin them down and go, what do you mean? Like, what experiment? You can just do that. Run through the scientific method. Once you know the purpose of it, it's so easy. And I think it's helpful for both sides, because a lot of people, if they're intellectually honest, they'll go, you know what, I actually don't know how I know that. Most people will not do that. They'll call you names. They'll call you crazy. One last thing before I stop this. My friend Daniel, who sent me this, so there's a lady who was working in a science lab, and she just came out against the whole COVID thing when she saw one of the recent documentaries. And my friend shared this testimony of this lady because it changed her world. She was like, I realized my whole career has almost been a hoax. And she was honest, and it's true. Well, he shared this with Jonathan Sarfati, who is a Christian creation scientist. You can't science creation, by the way. Sarfati wouldn't engage with us a couple years ago on this whole thing, just called us names, and he called this lady an anti-vax loon. That's all he said. For coming out and saying, I spent my life, I see the errors, I'm so, and that's all he got. And this is a Christian guy saying this. It's pathetic. And that's not how we should respond to anything like that. And it's the same when we hear stuff that we think is crazy, just like y'all probably think I'm crazy. Don't jump down people's throats. Just say, how do you know? Appeals to incredulity and be like, oh, well, that's just stupid. Don't do that. Try to at least look into it. I think we got to preterism probably by being open-minded a little bit. And I think, I find that preterists are more open to a lot of other concepts. So I'm not saying believe everything either. And here's the problem I see. Don't jump down the newest alternative path either. If something comes along and it's obviously against kind of the mainstream that you already know is false, don't just latch onto the false dichotomy, because that also has to be validated. I see this a lot in the truther communities where they love somebody else's news story or gimmick and they just run with that. And I'm going, no, that's just as much nonsense as this other stuff. You have to be careful, because it's easy, it's emotional, going, oh, finally these people are saying something I like. It's confirmation bias. And so make sure you're just keep a good clear head, I think, and always take a step back and go, I'll look into that. Funny, last thing, I promise. I finally, I have a friend, he's an online friend, but he's an ophthalmologist up in Iowa. And I think when all this about a year ago, he was starting to ask me about the COVID stuff, and I told him my views. And he did not like it. He went off on me, all this stuff. Finally this year, I stopped talking to him for a while because he was just belligerent about it. And he finally came back, he's like, I want to talk some more about this. I was like, you got to show me scientific validation. And he's like, I get it what you're saying. He's like, I understand there are problems with virology, that there's no scientific, but, and then he went into all this other stuff. And I'm like, I don't want to talk about it anymore, man. Like, I just want the scientific method. That's all I want. If you're admitting it's not there, it's good enough for me. At least he was able to say that, because this guy's like pretty left, like bought all the stuff. And so that was for me, I was like, holy cow, that's amazing for somebody like this to come out and actually admit it. Now, I don't think he'd admit that in public. Anyway, I wanted to bring that up because this stuff you're going to probably eventually hear more about this. And to a lot of people, it sounds just crazy. To me, it didn't at first, because I'm more one of those people that just goes, okay, I'll just go and I'll just look, because I've learned enough now in my life. I've had enough paradigm shifts that almost nothing surprises me at this point. Jesus came back in 70 AD, like, what? So yeah, it's true. And so, yeah, it's fun to look into all this. Anyway, I don't want to belabor it. I've been going a long time. So if y'all I know y'all probably have lots of questions. These are a few resources. Virus Mania is a good book. They go through a lot of these, very well done. If y'all ever want to, this is a brand new edition this year. AIDS, Opium, and Diamonds, and Empire by Nancy Turner Banks. She was an OBGYN. Awesome stuff. She goes into more of the big picture, world economics, lots of interesting stuff with that on the diamond trade and opium and all that. What really makes you ill, I'm friends with Dawn Lester. I've done an interview with her. Their book's about this thick. Not saying to believe everything on it, but it's very well researched, and it gets your mind going about all these other things that could be making people ill that it just aren't talked about. And breaking the spell is Dr. Tom Cowan, who's a retired doctor who's kind of gone into this stuff. And he was like me. He kind of bought the whole virus stuff until a couple years ago and started looking into it. And he's very sharp, and that book is about 45 pages. It breaks everything down as simple as you can if you really want to look into it. So that is all I got.